Hello student, today we are going to see NCRT example problem which is the 7th chapter class 11 physics. Okay, if you want more example and exercise problem means you can go and see in my playlist. I am given all the problems in chapter wise. So it is a 7th chapter, it's a rotation motion, the problem we are going to discuss. Okay, first we will see what is the problem is given. We have like this cylindrical shape paper roll. Okay, so imagine how it is a paper roll. Okay, so the mass we are taken as 20 kg, which is given in the question. The radius of this, it is a cylindrical shape, the radius of this is going to be 20 centimeter. Okay, so this side we are taken the paper. Okay, this side we are taking the paper. So the person is applied 25 newton. Okay, so 25 newton, so which is perpendicular to the radius of the cylinder. Okay, now mass of this is going to be given as a 20 kg. Okay, radius of this which is given as 20 centimeter, force is applied is 25 newton. This everything is given in the problem. Okay, now the question is asked, the first question, it is one, what is the angular acceleration? It is rotation motion, angular acceleration they asked. Second question, what is the work done? So what is the work done happened during this process? Okay, and third question, what is a kinetic energy? Okay, then final question, comparison of B and C. Okay, so these are the four questions is asked in this problem. Yeah, first I'm going to solve with first question. A, angular acceleration they asked. Okay, if you want to find angular acceleration, easily if you found the torque, you find the angular acceleration. Torque is equal to force into perpendicular distance. Okay, so we are going to find the alpha. If you want alpha, you can find torque easily, you can find the alpha. I'll tell you why. Okay, and force is how much? No, 25 newton. Perpendicular distance is a radius, so radius is given 20 centimeter. If you want to convert centimeter to meter, divided by 100 or into 10 power minus 2. Okay, so we can have 0.2 meter. When you are doing divided by 100, 0.2 or into 10 power minus 2, whatever way you want, you can do it. So otherwise 20 into 10 power minus 2, so the answer 0.2 meter. So I'll get torque. Okay, so 0.2 into 25, I'll get 5 newton meter. So I got now torque. You can have one question, they asked angular acceleration, why I am finding the torque? Okay, reason is there, I'll tell you. In rotation motion, torque is equal to I alpha. Okay, they are relating with inertia also, moment of inertia also. Already we found torque is it's a 5 newton. Already we found torque as a 5 newton. Inertia times of alpha. If you know what is inertia, easily you can find what is alpha. Okay, so inertia for the cylinder, which is given in the tabular column, mr square divided by 2. M is how much? Mass of the cylinder, which is 20, and radius of the cylinder, which is going to be 0.2, 20 centimeter, 0.2. Okay, so this square divided by 2. Now I am calculating what is the inertia of the cylinder. Okay, if you found inertia, easily you can calculate what is the alpha. Inertia is equal to 20 into 0.2 into 0.2 divided by 2. This if you cancel 10, 10 into 0.2 will have 2. 2 into 0.4, 0.2, I'll have 0.4. Inertia unit, kg meter square, because inertia is equal to mr square by 2. M is kg, r is it is meter. Okay, so r square is there, that's the reason meter square I wrote. Now torque is equal to I alpha, we are finding alpha, I you can bring as a denominator. So torque by inertia is equal to alpha. Now what is torque? 5 newton. Alpha we are going to find 5 newton. What is inertia? Inertia is going to be 0.4 kg by meter square. Okay, so if you want to cancel this, easily you can do just multiple with numerator 10, denominator 10. Because we can remove the decimal, 50 divided by 4. 2 table if you are cancelling, 25 divided by 2. 25 divided by 2 will have 12.5. it is alpha. Alpha unit, what is alpha unit? Radian per second square. Okay, now I got what is the angular acceleration. So first question we got what is a angular acceleration, which is going to be a 12.5 radian per second square. Second question they asked what is the work done. It's very simple. B question is a what is the work done. Work done is equal to force into displacement. How much force? Okay, so force applied 25 Newton. Okay, so displacement of the paper roll, okay, which is given as a 2 meter. Okay, in this question, the displacement is 2 meter, which is given in the question. So 25 into 2, I'll get 50. It is work done. Work done is also energy. The unit will be joules. Okay. Second one, what is the kinetic energy? C. Okay, it's a second. It's a for this answer. What is the kinetic energy? Usually we know kinetic energy is equal to of mv square. It is for linear motion. If same thing, kinetic energy, if you want rotation motion, of m is going to be rotation motion inertia, velocity we can take it as an angular velocity. Like this we can take it. So from this we know inertia is going to be 0.4. But what about the angular velocity? We don't know angular velocity. Sorry, angular velocity, yeah. So I am taking equation of motion, omega square is equal to omega naught square plus 2 times of alpha theta. Like that I am taken. Why I am taken like this? Because it is initially 0. Okay, initially 0. 2 times of alpha already we know. Okay, theta also we can easily calculate. Okay, so omega square initially 0 only, starting is 0. 2 times of alpha is 12.5 into theta. Now you need to know theta to proceed the problem. Okay, so now I can get easily omega square. Omega square is 2 times of 12.5 into theta. Finding theta also we have very simple method. Okay, it is a circular motion. It's made, it is a 2 meter. Okay, the displacement is 2 meter already is given. The radius of this circle is 20 centimeter. Okay, so theta will be arc length. Arc length is a arc length by radius. Okay, if you are doing this, you will get theta. Okay, in rotation motion, theta is equal to arc length by radius. In case theta means full circle means circumference of the circle 2 pi r divided by r. It's going to be 360 degree. It's correct only. Okay. So arc length is how much? 2 meter. That's going to be moment of the roll. Okay. So 2 meter. How much radius it is? How much radius it is? 20 centimeter. 20 centimeter you can write 0.2 meter. Okay. So you can multiple 10 numerator and 10 denominator, because the decimal denominator will go. Okay. 20 divided by 2 will have 10. Theta I got as a 10. Now omega square we can have 2 into 12.5 into 10. So 10 into this 125. 125 into 2, 250. Okay. 250 unit will be rad per second. Okay. How I got rad per second? Omega SI unit rad per second. Okay, it's omega square. So rad per second square. Radian per second square. Angular velocity is equal to angular displacement by time. So now I got omega. Next, I am going to find what is a kinetic energy. Kinetic energy for the cylinder of I omega square. Of is I is 0.4. Omega is 250. Okay, if you are cancelling this, 0.2. Okay, if you are multiplying this to what I can get? 0.2 into 250. So I'll get as a 50 joules or Newton meter also you can write kinetic energy. So I got the C answer is a 50 joules. Okay, so I'll do it here. Work done also I got 50 joules. Force into displacement. Kinetic energy in rotation motion also I got 50 joules. Okay, so the final answer D is going to be the comparison of B and C. Okay, just we have to compare this two. Okay, in rotation motion and linear motion, work done is equal to kinetic energy. That's the thing, D answer. Okay, both is going to be the 50 joules. Okay, so energy getting conserved here. Okay, neither be create nor be destroyed, energy maintaining as a constant. Thank you for watching my channel. If you like my channel, please subscribe. Thank you everyone.